Hello, my esteemed viewers. After having gone through some necessary fundamental aspects of force system, and engineering mechanics in general, in tutorial 1, we probe little deep into the concurrent force systems. Of course, coplanar concurrent force systems. In the real world scenario, we find many concurrent force systems. It could be the forces in the spokes of a bicycle radiating in several directions, all around 360 degree, acting at the hub. The weight of a traffic signal and the wires used to hang the same, maybe atop the middle of a junction of a road or junction of roads. The weight over the inclined plane and the components of the weights. One in the direction perpendicular to the incline, the other the frictional force, another component of the weight which is acting in the downward direction of the slope at the mass center of this particular body, and the forces acting over a hook in a bid to pull the hook out of the wall at the top tip of a tower, which is being held fast, which is being tied, which is being supported by guy wires. Here you can see 1, 2, 3 guy wires, and this is the point of concurrency. This is the point of concurrency. And the forces acting on the tie wires of a parachute, and the forces developed at every joint of a truss structure, something like this, are all examples of concurrent force system. In reality, we find the forces, concurrent forces, are forces emanating from a point, or force acting towards a point in a concurrent force system, may come in various directions. Look at this. And this particular trolley also represents a concurrent force system, and so also this. This trolley, being of higher weight, is trying to pull this small trolley in the upward direction, and there is a force which is responsible for making this small trolley to move up. It might have started from this particular point. Slowly it will rise up. Slowly it will rise up. When it moves in this particular position, let us say, we should take it as it has moved in horizontal direction from here till here, let us say, and it is also moved in vertical direction from here till here. It was here before, now it has gone over here. And if you can just notice very carefully, it is moved in horizontal direction, it is moved in vertical direction. Therefore, a force F, which is inclined at an angle of theta with respect to x-axis, let us say, will have horizontal effect and vertical effect. We will cut this force to scale, something like, let us say, 1 centimeter equal to 10 kilonewton. Therefore, we can cut this particular force to a scale, and we will project horizontally to find the horizontal component and the vertical component. Therefore, this force, the horizontal component of the inclined force, is responsible for the movement or disturbance along horizontal direction, and this is responsible for the movement of this, let us say, for this small trolley in vertical direction. Therefore, an inclined force is to be seen for having the effect in horizontal direction and vertical direction. That means this force can be removed if and only if the horizontal effect and vertical effect of this force is retained. And we can get to know as to the magnitude of this Fy and Fx by simple relation. And if we take sin theta equal to Fy that is opposite by hypotenuse F. Of course, these forces are scaled. Therefore, we can always apply the principle of trigonometry applied to triangles. And Fy, therefore Fy equal to F sin theta. Therefore, vertical component in this case of the force F is F sin theta. In the same token, if we take cos theta, we will get Fx, that is adjacent by hypotenuse. Therefore, Fx equal to F cos theta. Therefore, the horizontal component of this inclined force is F cos theta. And had we referred this force with respect to vertical, and here we have referred with respect to horizontal, and here the magnitude will change. And here if you take cos theta is Fy by F, that is adjacent by hypotenuse, and we will get Fy equal to F cos theta. That means here Fy was F sin theta because the angle of reference was with respect to horizontal, and here the angle of reference of this inclined force is with respect to vertical. Therefore, Fy equal to F cos theta. And in the same token, if you take sin theta, which is opposite by hypotenuse, we will get Fx equal to F sin theta. Therefore, here in this case, vertical component will come with sin theta, that is F sin theta, and horizontal component will come with cos theta. Vertical component will come with cos theta, vertical component, and horizontal component will come with sin theta. To remember this very easily, we will get the component in terms of cos theta. The component which is attached to theta, we will get cos theta, and here it happens to be horizontal, here it happens to be vertical. Therefore, the other component will be followed by sin theta. So they are counterparts. Sin theta and cos theta are counterparts, and it is very important to realize which is the horizontal component and which is the vertical component, and we should meticulously work out the horizontal component, that is horizontal effect of an inclined force and vertical effect of an inclined force. And we have this procedure of breaking an inclined force into its components is called as the resolution of a force. Resolution of a force is about finding the components of the force, one in horizontal direction and one is vertical direction. It is not that we always resolve the force only in two directions, that is horizontal direction and vertical direction. In fact, a force can be resolved into its components along any specified direction. But in engineering practice, particularly in designs, we are bothered most of the times. We are bothered about the horizontal effect of a force and vertical effect of a force. Therefore, we choose throughout this course of engineering mechanics resolving the force into horizontal component and vertical component. But in mechanics, we often prefer to resolve the forces in the two orthogonal directions. So if this is the weight, if this is a block which is moving on the incline, we can definitely, the weight is the force over here. There are no other forces present, and weight is the force which is weight of this particular block. It can be, and if this is the theta, that is the inclination of the incline, this is a vertical line, that is a weight line, and this is a line normal to the incline. Therefore, we can resolve the forces not necessarily along horizontal x-axis and y-axis. We can make this incline, the direction of the incline to be x-axis, and a line perpendicular to this incline can be y-axis. Therefore, we can resolve the forces with respect to the incline. So this force becomes horizontal force, that is parallel to the incline, and this force will become vertical force, that is vertical to the incline. And therefore, depending on the context, we will resolve the forces only in horizontal direction and vertical direction. To what reference that we resolve is very specific to the given problem, as it is explained over here. This is W cos theta and this is W sin theta, because this is theta being angle of incline, and it is W sin theta which is disturbing or making this particular block to move down the incline. Okay, and the vertical component vertical component of the component which is perpendicular to the incline will make this block to sit little tightly over the incline. Anyway, if the effect of W sin theta exceeds the effect of this pressing force, then this particular block will show a tendency to slide the incline, and therefore it is the component along the incline which is the cause for bodies to move down the incline whenever they are placed on the inclined plane. Right. Resolution of a force with reference to a point of application, and we need to resolve a force keeping in regard as to what is the point of application. Point of application really matters when we resolve the forces. And here this inclined force F is acting at this particular point. Therefore looking into the sense of this particular force, horizontal component will be rightwards and vertical component will be upwards, and this is positive y and this is positive x. Fx equal to here F cos theta and Fy equal to F sin theta. And in this case, a force, this is the point of application. Therefore, this is the vertical component and this is the horizontal component. But anyway, the angle of reference comes with respect to vertical. Therefore, this will become F cos theta and this will become F sin theta. Here F sin theta is negative and F cos theta is also negative because the force is going down and this force is going left. And here also this is F cos theta and this is F sin theta. This is positive but this is negative. Here like this we can draw several examples in order to reinforce our understanding about the resolution of force. And if this is F sin theta and this is F cos theta. Here horizontal component is negative because it's going left, and this is vertical component which is positive. And here too this is the point of application. This is the point of application. Let us say if the force is coming down and this is F sin theta negative, F cos theta positive, theta is referred with respect to x-axis. Here this is the point of application, and this is F sin theta, and this is F cos theta, and this is F sin theta. F cos theta is vertical component, F sin theta is horizontal component. Both are positive in this case. And this is the sign convention that we have. Forces going up is positive, force coming down is negative, force going horizontally right is positive, horizontally left is negative. Now we have composition of force also. Let us say we are given with two forces, one acting horizontally, other one acting vertically. We will cut them to scale. It will become like this. This is 660 kilonewton Fx, and this is 40 kilonewton Fy, and we have cut them to scale, and we will draw this. This will become the resultant according to triangular law of vectors. Okay, and this will become the resultant. Simple Pythagorean theorem or Pythagoras theorem will help us to find out what R is. So R equal to, this is Fy, this is Fx, and this is the R. They were there, Fy was there and Fx was acting on the system, and we removed them and we replaced them by a single force, and the single force becomes resultant. Therefore resultant of a force system is represented by is a representative force which represents all the other forces acting on the system. So here it is single force. Therefore this particular principle can be applied for a system which is acted upon by several forces acting in several directions. And here we just try to understand as to how resultant can be calculated. So resultant equal to the length, the magnitude, which is Fx square plus Fy square according to Pythagoras theorem, and tan theta, the direction of this particular resultant should also be obtained, which is equal to opposite by adjacent. Opposite is Fy and this is Fx. Therefore theta equal to tan inverse of Fy and Fx. And therefore if you take a typical example, R equal to 40 square, that is vertical force square and horizontal force square, and we will get theta equal to tan inverse of 40 by 60, which happens to be 33.7 degree. And this is how, and this particular methodology is applicable, can be extended to be applicable for a system which is subjected to many forces. What we have to do is calculate the horizontal components of all the forces, compute the vertical component of all the forces, take an algebraic sum. When we take an algebraic sum, we are really mindful about whether the force is positive or negative. In arithmetic sum, we will, regardless of the sign, we will just add. Okay, and this we should not do. When we say positive horizontal force, it is going towards rightward, the effect is towards rightward direction. And when we say a vertical force negative, the effect is vertically downwards. It is something like this. And same technique can be extended for finding resultant of any number of forces acting concurrently at a point. Therefore, this method reduces to finding resultant of a concurrent, of course, coplanar concurrent force system. So we will go one after the other. This is a typical example. A sphere is subjected to several forces, F1 to say Fy, acting concurrently at this point. This force is trying to pull up this sphere. So also this. However, F4 and F3 is trying to push at the point of concurrency, and this should be equal to and we will find the algebraic sum of all the horizontal components of the forces, horizontal component of F1, F2, F3, F4 and Fy. That will be captured in sigma Fx. And similarly, and we will find out the vertical component of all the forces, F1, F2 up to Fy, and that will be culminating in sigma Fy. Of course, it's an algebraic sum. Let us say it emerges out to be a single horizontal force after algebraic summing, and this is the single vertical force, which can be designated as sigma Fy. And this should be the resultant. We will cut this to scale and we will find the resultant and its direction also. So here the horizontal force is sigma Fx, and vertical component is sigma Fy. Resultant value is square root of sigma Fx whole square and sigma Fy whole square, and tan theta equal to tan inverse of sigma Fy divided by sigma Fx. And it is very interesting to know that it is the Danish mathematician and engineer Simon Stevinus, who lived during 1548 to 1620, years and years ago, was the first to demonstrate resolution of forces. And he showed that forces can be resolved, thereby establishing the foundations of modern statics. So we will do 3 or 4 illustrative problems to consolidate our understanding about finding the resultant of a concurrent force system. So find the resultant of the force system shown. Here there are two forces, one 10 kilonewton. See, the location, the orientation of this 10 kilonewton is explained by how long it moves, how long it can be scaled. This is to explain the slope of this particular force. So 3 meter horizontally, 1 meter vertically, and 15 kilonewton is acting at the same point of concurrency in the direction shown, and it makes an alpha, and to reach this particular point we have to move 2 meter horizontally right and 3 meter vertically down. And therefore this will help us to find out the inclination of these forces. So as far as this thing is concerned, this inclination is concerned, tan theta equal to opposite by adjacent 1 by 3, therefore theta equal to tan inverse of 1 by 3, 18.4 degree. And as far as alpha is concerned, tan alpha equal to 3 by 2, and alpha equal to tan inverse of 3 by 2, it will give us 56.3 degree. Therefore this inclination is 56.3 degree and this inclination is 18.4 degree. And of course, since our horizontal component and vertical component reduces to sin theta and cos theta, we can also find out the length of this line. Assuming that it is a simple line, so it is 1 square plus 3 square under root. It will get this hypotenuse dimension, and so also this we can use them directly, the ratios, whenever we use sin theta and cos theta while we resolve the forces. And here sigma Fx equal to and here the horizontal component of 10 kilonewton comes this way. It goes this way, and vertical component goes this way. So vertical component is positive, horizontal component is negative. Horizontal component is minus 10 cos 18.4 degree. And as far as this force is concerned, horizontal component goes like this and vertical component goes like this. How I am able to write the arrows? While I represent the sense of these forces, I will look into this particular arrow. This is the parent force, which gets resolved into its components, horizontal component and vertical component. So this is 15 cos 56.3. It is positive. This is positive. Yeah. Right. We'll take them away so that for the sake of clarity, right, because they are not looking like horizontally vertically together, because I wrote that way, right. Now we'll go further. We will find out Fx. See, Fx happens to be minus 8.32. In the same token, the sigma Fy is 10 sine theta, 10 sine 18.4 going up, and this is coming down. The vertical component is coming down like this. It is minus 15 sine 56.3, and we will get minus 9.32. Now there is no need to hold this particular figure in our mind. We can just remove this and we can replace this entire system, and this entire system is equal to one horizontal force which measures minus 8.32 kilonewton going this way, and one vertical force which is going down because of minus sign. It is 9.32 kilonewton, and the resultant and the theta of inclination is over here, and this is the resultant, and this resultant can be established. So once again it is being written over here, 8.32 going this way, 9.32 coming this way. This should be the resultant. Of course, this resultant can be gotten by just projecting this vertically by dotted lines, maybe horizontally by dotted lines, and we meet this particular point in order to get the length. And we use the principle of triangle, right angle triangle, of course. Therefore R equal to the length of this, the magnitude of this resultant equal to 8.32 square plus 9.32 square. And it is very important to realize that negative sign doesn't hold water over here, because it is going to be squared. It's going to be squared. So R emerges to be in some kind of an absolute value. So R happens to be 12.5 kilonewton, while tan theta is or sum of the vertical forces, that is 9.32 divided by 8.32 horizontal forces. Therefore theta equal to tan inverse of this thing, and we will get 48.24 degree to be the direction of the force with respect to horizontal. So we need to explain something like this while we conclude the resultant of this particular system. Resultant of this system is if 12.5 kilonewton, and it is inclined at 48.24 degree to the negative x-axis in anti-clockwise direction. Right. We will go to some next problem. Two tugboats apply the forces. This is tugboat, which are used to tug this main ship. Let us say to drag this main ship. This is a barge. It's also called as a barge, and here is a barge, and these barges are used to even anchor big ships over the sea. Okay, where P is 76 kilonewton, Q is 52 kilonewton. Determine the resultant of P and Q. That is the question. Therefore here again we will calculate the inclination of P, which is tan theta. It is theta is over here. Theta is over here. Yeah, we will write that. This is theta. So that is equal tan theta equal to 32. That is opposite by adjacent. Adjacent is 16. It is given over here. It becomes 63.43. 63.43. Similarly, and this is the angle. And alpha, this is the angle, which is tan alpha equal to 12 by 24, opposite by adjacent, we will get 26.56 degree, and this is the angle, and this is the angle, and we will just mark that also. Yeah. Now sigma fx. So the horizontal component of this 76 kilonewton will be going like this, and I just showed this by looking into this particular arrow tip. So therefore it is negative, minus 76 cos 63.42, because theta is referred with respect to horizontal, and this will have 52 cos 26.56, because this angle is 26.56, which goes this way. So this is positive horizontal component, and this is negative horizontal component. Summing together, it will give us 12.551, which is positive, which is going like this, because this system is equal to this particular system, one horizontal force and one vertical force. We remain to see as to what this vertical force is. 76 sine 63.43, that is going vertically up, positive of this particular force, and this is coming down. The vertical component of Q is coming down. It is minus 52 sine 26.56 degree, and we will get 44.72 positive going up. Therefore the resultant is 12.52 square plus 44.72 square. The real meaning of this resultant here is, if one tugboat were to draw this big ship in this direction, the other tugboat is to draw this particular ship in this direction, it will go not in this direction, either in this direction or in this direction. Instead it will take a path along this particular direction. Probably it will move something like this. And we could have applied law of parallelogram of forces also, but anyway, since we are accustomed to as a engineers and referring and using engineering mechanics principles, we always try to resolve the forces in vertical direction and horizontal direction. This directionality of the resultant indicates in what direction this ship will be able to move. This ship will be moving parallel to this particular resultant, and this resultant is inclined at an angle of let us say tan inverse of sigma fy, that is 44.72 by sigma fx. It is 74.37 degree. This is 74.37 degree. So it moves in this direction at an angle of 74.37 degree, and that's what may be needed, and that is the direction that is needed in order to make a movement. Therefore a system which is having a resultant will always be imbalanced. This is a very important point that should be driven home, right? The third problem is, a ring is subjected to forces as shown: 180 kilonewton, 65 newton, 56.4 newton, 45.2 newton at various angles of inclination. Here inclination is directly given, and here slope of this particular line is given, slope of this particular force is given. 4 horizontal, 3 vertical. Therefore we can calculate the theta, and the theta comes over here. Of course theta comes over here, that is required. This is theta, this is theta, therefore this theta is applicable here also. So tan theta equal to opposite by adjacent, 3 by 4, theta equal to tan inverse 3 by 4, that is 36.86, and we will go on resolving the forces, and we will just accrued what sigma fx is, sigma fy is, and this force we will detach each and every force for the sake of clarity away from the main figure, and we will find out the result, find out the components. This has to be done in every exercise, in every problem, in order to avoid errors. And this is 80 newton, and it is in 80 cos theta, it's going right, and this is 80 sin theta. And as far as this force is concerned, 45.2, this is 45.2 horizontally, positive horizontal force and negative vertical component. Theta is referred with respect to horizontal. And here 56.4 newton is going like this, and this is the vertical component, this is the horizontal component, justifiably so. This angle is 45 degree referred with respect to vertical. Therefore this will become sine theta and this will become cos theta. Okay, 56.4 minus, because it is going leftwards and this is going downwards, 56.4 cos 45, and this is the resultant. And we will, and as far as 65 Newton is concerned, 65 is going like this, parallel to this, and this is the vertical component and this is the horizontal component, and it is minus 65 cos 36.86, and this is plus 65 plus 65 sine, and this should be plus, sorry, it should be plus plus 65 sine 36.86. Yeah. Now we will add all the forces to obtain sigma fx. We will add all the horizontal components of all the forces. 80 cos 30 minus 65 cos 36.86 minus 56.4 sine 45 and plus 45.2 cos 60, and we will get minus 0.10 kilonewton, which can be said to be negligible. And Fy on the same token, 80 sine 30 positive going up, plus 65 sine 36.86 positive going up, minus 56.4 cos 45 negative coming down and negative coming down. We will get the algebraic sum of all the vertical forces in the system happen to be the very meek. And if you find the resultant is also very low, but anyway there is a resultant. There may be a small disturbance which can be negligible, of course. Therefore there is no significant effect of the resultant as far as that particular system is concerned. Now we will come to the fourth problem. The two forces P and 5 kilonewton act on the structural member AB, some structural member, say some crank, some bar, okay, some member which is positioned something like this. This is the hinge. That means this particular bar can rotate this way and this way. Okay, that is the nature. Anyway, this particular bar is supported. Let us have that particular understanding as far as this problem is concerned. Determine the magnitude of P, one of the forces, such that the resultant of these forces is directed along AB. And we need the direction of the resultant has already been given. The meaning of this particular problem is direction of the resultant is already given, because we need to find P such that the resultant of these forces is directed along AB. That means the directionality of the resultant is fixed. It should be along AB. So here we never go back to the concept of resolving a force with respect to horizontal direction and vertical direction. Therefore we need to resolve these two forces with respect to the direction along AB, which may become possibly x-axis, and across AB, that is perpendicular to AB. Okay, and that may be regarded as vertical forces or vertical components going across AB and horizontal components along AB. So we will just make a diagram, okay, of course taking away all the other necessary details. This line represents the line along AB, which is inclined at an angle of 70 degree, and this is the line, purple line, which is perpendicular to, and of course this angle is 90 degree. This angle is 90 degree. Yeah, we have to do like this. And so we drew the system of axis or system of references along which the two forces are to be resolved. And here comes 5 kilonewton, and here comes P, and this 5 kilonewton is inclined at an angle of 40 degree with respect to horizontal. We can see over here, and this line is inclined with to 70 degree with respect to horizontal line. Yeah, therefore this angle is 70 degree and this is 40. this is 40, and here till here is 90 degree. Therefore 90 minus 70 happens to be 20. Therefore this inclination is 20 degree. This force is inclined with respect to the line AB at 30 degree, because here till here it is 70. 70 minus 40 is 30. That means, yeah, it's going to come, nothing to worry. And this is 20. This is 20, because here till here it is 70. 70 minus 30 is 40 is 30, and this is 20. Now this is AB, okay, this is P, right, that is CD. The perpendicular axis is CD. The perpendicular axis is named as CD. This is CD, this is AB, and we got various directions. P is inclined at an angle of 40 degree, because here till here it is 60, here till here it is 60, and this angle is 20. And if you just project this, this angle is 20. Okay, this angle is 20. From here till here it is 20. From here till here it is 60, which is given. Therefore this angle is 40 degree. Therefore P makes an angle of 40 degree with respect to vertical line with respect to AB. Okay, and it makes an angle of 60 degree. This 5 kilonewton makes an angle of 60 degree with respect to the vertical line drawn to AB. So, and we remain with the two axes, one along AB and one along CD. Now we will resolve them, and once again it is drawn for the sake of clarity. Now we will just go on resolving, and this is the resultant. That's what expected. The resultant should be along AB. So in order that the resultant of these two forces is along AB, what is the amount of force over here? P. P is the unknown over here. Resultant is not the unknown. Okay. Now it may go like this. Let us see. The algebraic sum of forces across AB equal to 0. It is algebraic sum of forces across AB. Across AB means it is CD. This line is named as CD, let us say. So 5 cos 60. So this is 5, and this 5 kilonewton is inclined at an angle of 60 degree. Therefore it is 5 cos 60. It goes like this along this particular axis. Yeah, we'll draw that. So 5 cos 60 goes like this along this particular axis. Positive, right? Therefore it is positive. Then P cos 40. This angle is 40 degree. This angle is 40 degree. Okay, because from here till here it is given to be 60 degree, and this angle is 20 degree, vertically opposite vertex angles. Okay, 20 degree. Therefore this is 60 minus 20 equal to 40. Therefore it is 3.25. P cos 40. P cos 40 is going like this. Therefore it is negative. This is positive rightwards, this is negative leftwards, because this axis, this purple axis, is considered to be x-axis, let us say. Okay. Yeah, now we will continue. Right. So 2.5 minus 0.77p equal to 0. Because the question is find the resultant along AB. Along AB means the effect is only along AB. The effect perpendicular to AB is equal to 0. That's one and the same. And if you are asked to find the resultant along AB, the directionality of the resultant is fixed, and we are making this particular axis to be, let us say, y-axis, and this to be x-axis. There is no effect of the resultant along x-axis. And of course, the resultant effect along x-axis is sum of the horizontal components of all the forces. Here there are only two forces. Therefore, the horizontal component effect of this force and this force should be 0. That is the logic over here. 5 cos 60, 2.5 minus 0.77p equal to 0. Therefore P will be 3.25 kilonewton. This is the value of P. and we go further to find the value of the resultant, which is along AB. Therefore, resultant along AB is, resolve the forces along AB. We know P now, so it is going to be P sine 40, sorry, P sine 40. 3.25 sine 40, it is going in this direction, and so also this 5 kilonewton, 5 sine 60 from here till here, 5 sine 60, which is also going like this, because if you look into this arrow sense, it has to go in this direction, this should also go in this direction, this can be considered as positive direction, and in order to realize this, we need to rotate this coordinate system, and AB should become vertical and CD should become horizontal. Then the things will be understood very clearly, and the resultant happens to be 6.42 kilonewton, while P equal to 3.25 kilonewton. P is tailor-made in such a way that the resultant goes only along this direction, that is along y-axis. The resultant is directed along this y-axis or AB axis. That means to say the effect of the resultant along this particular line is 0. Therefore, sum of the horizontal components of these two forces equal to 0. That is the logic of this particular problem. To conclude, this tutorial clearly explained how we can find the resultant in a concurrent force system. Of course, coplanar concurrent force system. It is very important to realize such systems will be in a state of imbalance. Any system, as a matter of fact, if it possesses resultant, it will be in a state of imbalance, because there can be a horizontal jerk, there can be a vertical jerk. In the next tutorial, we probe further deep into little complex or tough problems and a concurrent force system. Until then, bye, and if you have liked this video, kindly subscribe to my channel. Thank you.